for us to, in code, create references to user interface objects that we've created in Interface Builder. And actions allow us to specify what code to call when we get an event on one of our controls. And as we'll see, you can actually, in Interface Builder, you can control drag to attach an outlet or an action. So what's an outlet? An outlet, you declare it using IB outlet, which is completely ignored by the compiler, but it's just a flag for Interface Builder to say, hey, pay attention to this because I'm going to try to hook this up to, I'm going to hook this variable up to an actual object in the interface. Yeah. One thing to be cautioned is I forget when I talk about this, but there's a method called awake from nib, which gets called when your code is launched, when you have a view that's in a nib file, which is what you saw at XIB. It's a newer version, but the same idea. Awake from nib will get called after everything's been loaded in that nib, so you're not guaranteed that your outlets have been connected until then. So if you try to do something to one of your buttons in your initializer, that view might not be totally loaded yet, so that actually wouldn't work until awake from nib has been called. Just something to watch out for. But I think we'll talk about that a little bit more later. And actions, there's another flag that's IB action, which is the same as void, in fact. And again, this is just a way for us to flag a method as one that Interface Builder should be interested in, and one that Interface Builder can see. So that way, when I want to make some button do something, it's a method that I'm allowed to call from that button. On OS X, there's the sender parameter, which is when an object calls one of these methods, it will pass itself in as the argument to that method. So on OS X, that's actually required that all actions have a sender. On iOS, it's not, but it's often a good thing to do anyway. And on Mac, you can set targets and actions on your controls in code. You can also do it in Interface Builder, as we'll see. But I mentioned this before. There's a target action pattern where you set the target, which is the object to which you want to send a message, and then you set the action, which is the message you want to send when something happens. On Mac, controls only have one event, so there's the button got clicked or the slider got slid. On iOS, controls can actually send a bunch of different actions depending on different events. On Mac, there's one. There's the action that button does when its event happens. There's only one event allowed for every control. So just a little bit about nibs. Nibs, you might think, are generated code, and then that code just gets called when the application launches. They're actually not. If you were to look at a zip file itself, it's actually an XML property list. It's basically the idea is, if you've heard of, in Java we talk about serializing objects, basically writing objects out to file. A nib is a bunch of objects written out to file, and then when you load a nib, that file just gets read and everything gets created on the fly, kind of just reading things out of the file and then creating them and putting them on the screen. And then once it's done doing that, it calls this method awake from nib. And at that point, you're guaranteed that everything that's in the nib is there and loaded, and if there's outlets, they're all connected. Until then, you don't have that guarantee. Okay, so to kind of give you a slightly more concrete example of MVC, suppose we're writing an address book application. Our model is probably a person that has a name, a photo, and an email. And here's maybe what our view looks like. And you might be tempted to do this. Just have that view communicate directly with the model to get its data. And as we've seen with MVC, this is not a good idea because, again, what if we change the model or change the view? Then all that logic of how they interact has to change. And if we have a controller object instead that they communicate through, then changes to the model don't have to cause code changes in the view, and code changes in the view don't have to cause code changes in the model. Obviously, you're going to have to change a little bit of code in the controller to make sure that handshake still works, but it's considered a cleaner way to handle this problem. So suppose we click that email, then that view is going to send a message to the controller, which will then tell the model, okay, what's that email? I'm going to go send an email to that person. Okay, so let's get more sophisticated with that slider, and let's actually make it do something. Okay, so we want to have the slider, anytime the slider's value changed, we want to know about it. So that sounds like this slider needs a what? Action or outlet? An action, because something's going to happen and we need to tell some bit of code, hey, something happened. I could make some, I'm just going to use our app delegate object to handle that. Since this app is so simple, I don't really need to make a controller. I'm just going to let our app delegate be the controller. Yes?
What does strong mean?
Oh, this has arc set. If you haven't seen automatic retain count, that creates a strong reference as opposed to a weak reference, which just basically tells automatic retain count how to handle retains and releases on that object. That's actually a good point because I don't like using automatic retain counting. Is it in there? Okay, so let's make an action for when that slider gets changed. So what's the return type of this method going to be? IB action, which is, and you can see it knows that I'm writing an action, so it gives me some template code. Let's call it, I don't know, slider changed, because this is going to get called every time the slider's value changes. Okay, and then let's implement that with a really simple implementation that just kind of logs out the slider's value. And since I know this is a slider, I can actually retype this as slider. And you could leave it as IB action. I kind of just like to leave the IB stuff in the header just to make things because the interface builder isn't going to look at the implementation file anyway. But whatever. Okay, so let's just log out to the console. We're going to get float. Sender value. Actually, can we do float value? Yes, we can. Cool. Yeah. So one cool thing about controls on Mac is that they have a concept of value. So you can most controls you can ask for its integer value, its float value, its string value, all these different things, and some of them don't make sense depending on what the control is, but if you have a text field that has a number in it, you can ask it for its number value, and it will do the right thing. Okay, so let's just run this, and I didn't... Oh, hang on. Well, let's run this and see what happens. And let's get the console open. Oh, so small. No, wrong. Okay. And yay, it doesn't get logged. Why doesn't it get logged? Anybody have a guess? We haven't connected it. So, how do we connect it? Let's go back into our nib. And if we look, I believe, is the file's owner the app delegate by default? Yeah, so by default, the main window is owned by your application's delegate, which actually is the first responder. In this case, the files, that's NS application, not the delegate. Is that going to know these outlets? Oh, jeez. Oh, right. OS 10 has all these different connections. Okay, so it's buried, but it's there. Yeah, the first responder on OS 10 does a lot of things. It's kind of responsible for handling all the keyboard shortcuts, like Command S, Command D, like all those different keyboard shortcuts are handled by the first responder, which is by default the application delegate. So that's why there's all these methods that are hooked up automatically, because they're all, you can see they're all hooked in from like different items in the main menu, like new and these kind of things. They all call some method on the first responder. Anyway, so we can control drag or right click from this to the first responder and then let go, and we can now choose what method to call when an event happens on the slider. So let's call slider changed. And now, if the demo gods are willing, we should get logs every time we move the slider. Or not. Oh, okay. So apparently we've set a property on the slider that it doesn't call it's changed until you've let go, until you're done sliding it. Just so we can see, if we go back to the inspector panel, we can actually say continuous, which, if I remember right, will send events constantly, basically. So every time it changes, and it has some threshold for how it determines how much is changed, but you shouldn't need to worry about that. Okay, so that's half the battle. Now we need to tell the label to change every time that we get a new number. So that since the labels, so what does that mean? What does that mean our code and this label need to do? Sorry, that was really poorly phrased. But that means we need an outlet to this label, right? Because the label's never going to call our code, because nothing really happens to a label. It just displays some static text. So that means we need a reference to this label, so that way we can change it when we need to. So the way we'll do this, we'll just declare an instance variable that's of type. Now you would expect the type to be NSLabel, but in fact it's actually just a text field with some special properties set by default, like it's not editable and it's not enabled and all that kind of stuff. On iPhone, there actually is a label class, which is different from a text field class. But on OS X, there's just... So let's just call it text field, or how about label? Okay. And it's pretty common to make these properties, just to make sure that their memory gets managed correctly. And you can also put the outlet down here. In fact, you don't need the outlet here if you put it in the property.
What are other types of property values, like non-atomic? What are other ones that you typically use?
Typically, anytime your application is not going to be multiple threaded, usually you say non-atomic because you can make it faster, because it doesn't have to put locks on it, locks and stuff on it. You can also say assign here instead of retain, so that way it just does a normal C assignment. You can also do copy, like we mentioned before, so that it makes a copy of that object and then assigns that. Those are the ones you use most often, I think. Are there any others you can think of that you use often?
Read-only.
Yeah, sometimes if you don't want it to be assigned, you can say read-only, so that way it can be read but not modified. And then let's go ahead and synthesize that. Okay, so now we can say label set float value sender float value. Quick poll, is this going to work?
No.
Why not? We haven't connected it yet. So we'll go back into our nib. We will look at our first response, and there's actually the kind of cool and confusing thing about this is we can do this in several ways. So we can either go to the first responder and look at all of its outlets, which are, where are they? Oh, because it doesn't know the class. Okay. Well, anyway, we should be able to control drag from here to the first response. Oh, you're gonna do this, are you? No, I have to go the other way. Sorry. You control drag, if you want to set an outlet, you control drag from the code, basically. Oh, come on. It's because you don't know what the class is, do you?